in this class we find out the Fourier series of a function fx. This is given by x square in minus pi to pi, and we have to show that the Fourier series of x square in this interval is given by x square. This is equal to pi square by 3 minus 4 into a series given. Okay, so we first evaluate the Fourier series of the function. Now we deduct three important results here. Okay, that is, we evaluate the value of three infinite series, this and this. Now we start our deduction of Fourier series of fx equal to x square. We first write the formula of Fourier series of any function, right? And this is given by fx, this is equal to x square, this is equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx plus bn sin nx. Actually the formula is an cos n pi x by l. Here l is also pi, so we cancel out pi by, so the angle is cos nx and sin nx. Okay, now we use the formula of Fourier coefficient, that is the formula of a0, formula of an and formula of bn. And the formula of a0 is a0, this is equal to 1 by pi integration minus pi to pi fx dx, and this is 1 by pi integration minus pi to pi x square dx. It is given that fx equal to x square, and clearly this is an even function, so we write this 1 by pi, sorry, this is 2 by pi integration 0 to pi x square dx, and that is 2 by pi into x cube by 3, so 2 by 3 into pi square by putting the range of the integration. And now an, what is an? An is 1 by pi integration minus pi to pi fx into cos nx dx, and this is given by 1 by pi integration minus pi to pi x square cos nx dx, and this is also even function because x square is even function and cos nx is even function. So we also write here 2 by pi into integration 0 to pi x square cos nx dx. We integrate this by using integration by parts. We get 2 by pi into, this is the first function and this is second function, so we get x square into sin nx by n minus integration, the derivative of first function is 2x and the integration of second function is sin nx by n dx, and the range is 0 to pi. So 2 by pi into this term is 0, totally 0, because if we put the range here, n pi sin n pi is 0 and for 0 x square is 0. So we write only second term and this is minus 2. Again we integrate this term, we get 2 by n minus 2 by n into x into integration cos nx by n, and this is plus here because integration of sin nx, this is cos nx, and minus, so this is also plus integration, this is the derivative of x, this is 1, and the integration of sin x, this is cos nx by n, and already 2 by n is here, and this is dx, and the range is 0 to pi. Okay, this is also negative because here minus 1 minus present, and from here we get minus, and in the formula there will be another minus. Okay, so 2 by pi into 2 by n square into x cos nx minus 2 by n cube into this is sin nx, because integration of cos nx is sin nx, and the range is, we write the range outside the integration this, and by putting the range we get 2 by pi into 2 by n square into pi, we put pi here, and cos n pi minus this is 0 because sin n pi is 0 and sin 0 is also 0, so the contribution of this term is 0, and we get the value is 4 by n square into minus 1 to the power n, because cos n pi this is equal to minus 1 to the power n, right? Now we find another Fourier coefficient Bn. What is Bn? Bn is most easy, 1 by pi integration minus pi to pi fx sin nx dx, and this is 1 by pi integration minus pi to pi, this is x square sin nx dx, and sin nx is odd function and this is even function, so the totally it is an odd function. So integration of odd function to minus pi to pi, this is must be 0, so this coefficient is 0. Okay, now putting the value of a0, putting the value of n and bn in the series, we get the Fourier series, and Fourier series of x square is x square, this is equal to a0 by 2, this means pi square by 3. Okay, because 2 cancel out, and pi square by 3 here, and this is plus summation n, this is equal to 1 to infinity, and putting the value of an, this is 4 by n square into minus 1 to the power n, 4 by n square into minus 1 to the power n into cos nx plus 0, because bn is 0 for all value of n, and this is written as pi square by 3 plus, if we put the value of n equal to 1 first, then we get a minus, so we first write a minus and take common 4, and this is cos x by 1 square. Putting the value n equal to 2, then we get this is plus, so we get this is plus cos 2x by 2 square. By we already take common minus, so this is plus and minus, so this is minus, and the third term is negative, but we already common here minus, so this is plus cos 3x by 3 square minus cos 4x by 4 square, and so on. Okay, and this is the Fourier series of x square, and this is our first proof. Okay, we already proved the Fourier series. Now to deduce the first result, that is the value of this infinite series, we use the endpoint, that is we use minus pi or pi. Okay, and we know that for Fourier series the value, if we put the value x, this is equal to pi or minus pi, that is plus minus pi, then we get the value of fx. This is given by limit h tends to 0. This is f of pi minus h plus f of minus pi plus h. Okay, because this is the endpoint minus pi, this is the endpoint pi, and we get the value of minus pi plus h, the right side value, and this for this point the left side value, and this is the value of plus minus pi. Okay, and this is given by limit h tends to 0. H tends to 0. This is pi minus h whole square plus minus pi plus h whole square, because it is given that fx equal to x square. Okay, now taking limit, this is another half, here also a half, and by taking limit we get half into pi square plus pi square, so we get the value is pi square. Okay, now we use any one of the extreme value, that is we put either x equal to pi or x equal to minus pi in the given Fourier series and get the result. The left side result is pi square, because we already find out the value of f of pi or f of minus pi, and the right side result is pi square by 3 minus 4 into, we write this first in compact form, n equal to 1 to infinity, this is minus 1 to the power n cos n pi by, this is cos nx, and this is n square. We write in compact form and put the value for x, this is pi, right, and we get this is pi square by 3 minus 4 into summation minus 1 to the power n into minus 1 to the power n by n square, because cos n pi, this is also minus 1 to the power n, and this is pi square minus pi square by 3, so minus 4 into summation minus 1 to the power 2n by n square, and this is 3 pi square minus pi square by 3, this is equal to minus 4 into summation 1 by n square. Okay, so we get this is 2 pi square by 3, and this is minus 4 into summation 1 by n square for n equal to 1 to infinity, and this gives pi square by 6 minus pi square by 6 and summation 1 by n square, n equal to 1 to infinity. Sorry, we make a mistake here, this is not minus, this is plus, so all of the sign is positive, so this is also positive. Okay, so we get the first value or the value of the first series, this is equal to n equal to 1 to infinity 1 by n square, this is given by pi square by 6. Okay, and we find the value of the last series or the third reduction very easily by multiplying both sides with half. Sorry, this is not half, this is 1 by 2 whole square, and we get this is pi square by 2 square into 6, this is equal to summation n equal to 1 to infinity 1 by 2 square into n square. So we get pi square by 24, and this is given by summation n equal to 1 to infinity 1 by 2n whole square. Okay, so we get the second result, this is given by pi square by 24. Now we write this result in expanded form and also this result in expanded form. We write as the first result is pi square by 6, this is equal to 1 plus 1 by 2 square, 1 by 3 square, 1 by 4 square, 1 by 5 square, 1 by 6 square, 1 by 7 square to infinity. And from here we get pi square by 24. This is given by 1 by 2 square, and second term is 1 by 4 square, and third term is 1 by 6 square, okay, and fourth term is 1 by 8 square. That is, we get all the even term. Now if we subtract, let it be 1 and it be 2. Now if we subtract 2 from 1, then we get the result as pi square by 6 minus pi square by 24. This is equal to 1 plus 1 by 3 square plus 1 by 5 square plus 1 by 7 square and so on to infinity. And this is given by the LCM is 24. This is 4 pi square minus pi square, and the right side is summation n equal to 1 to infinity 1 by 2n minus 1 whole square, and this is 3 pi square by 24. This is equal to summation n equal to 1 to infinity 1 by 2n minus 1 whole square. That is the result of the series summation n equal to 1 to infinity 1 by 2n minus 1 whole square. This is equal to pi square by 8. Okay, and the last result is pi square by 8. This is very important Fourier series, and we make all the 3 very important deduction from the Fourier series. Okay, thank you for watching.